Okay, so this is the first video in Unit 3, and this video is going to be talking about simplifying expressions. But before we get started, I've got a really terrible joke for you. Why did the math teacher keep walking into his classroom with sunglasses on? Because he had such bright students. Yes, pretty corny, I know. Okay, anyways, the I can statement is simply to simplify expressions using properties of operations. Here's your agenda. I won't bother reading the whole agenda out loud to you, but basically we're going to just do a little review, examples, and that's about it. Okay, to understand what we're going to do today, you've got to understand some properties of addition and multiplication. So this commutative property of addition means that a plus b also equals b plus a. In other words, 2 plus 3 is the same thing as 3 plus 2. You can switch numbers around and it doesn't change the fact that you're going to get 5 in this particular case. That's a pretty easy property. The associative property also works for multiplication. It means that you can change the grouping. And the way I remember this is I think associative means like to associate with someone. So the A is sort of associating with B here, and the C is kind of left out of the group. And on the other side, the B is associating with C and A is left out, but they all equal the same thing. Now remember, parentheses generally means do me first. So 2 plus 3 is 5, plus 4 is the same thing as 3 plus 4 is 7, plus 2. You end up with the same thing at the end of 9 equals 9. So this property, both of these mean that even if you group them differently or switch them around, you're going to get the same answer. But now we're going to talk about one property that's a little stranger. It's called the distributive property. Now I know everybody here has been exposed to this before, okay? And this is key. This is key to this whole lesson. Now normally, parentheses mean do me first. But when we use the distributive property, we're actually going to kind of break that rule and apply another rule, okay? So A times, this is what this means here. This the fact that the A's all the way up against this parenthesis means A times whatever's in the parenthesis. So what we would normally do, if we had this over here, 2 times 5 plus 3, is we'd normally go, okay, 5 plus 3 is 8, and 2 times 8 is 16, right? That's what we would normally do. But the distributive property says we can break that PEMDAS rule just for a minute, just with the parentheses, and we can say, okay, this is equal to 2 times 5, which is right here, plus 2 times 3, right here. In other words, we're going to distribute the 2 to both numbers inside the parentheses. So this is equal to 2 times 5 plus, and I use the plus sign because there's a plus or an addition sign in here, plus 2 times 3, which is 10 plus 6, which gets us 16. Now if we had done it the normal way of 2 times 8 and the distributive way of 10 plus 6, we end up with exactly the same thing. That property is important for us as we try these examples. Okay, let's go to example 1. Okay, simplify the expression, combining like terms. We talked about that a little bit already. Well, when you're faced with something that looks like this, the first thing that you have to do is you have to get rid of the parentheses. So I distribute to get rid of the parentheses. Now, what's interesting about this is there is no number right here or right here to distribute to each term. When there's no number, we assume that the number is 1. So in this case, there's an invisible 1 here and an invisible 1 here, and 1 times all this is just going to be this. And plus 1 times all this is just going to be this. So in essence, this is super easy. You basically just remove the parentheses because there's no number to distribute here. So this first step was actually kind of not needed. I just put it in there so we'd be consistent. Oh, let me erase this part here first. Okay? It says use the commutative property to place like terms together. Now we did a little bit of this already, but what I mean is right here you see that the like terms we have x's and then we have no x's. They go together. Well, all I did was I just switched them around using the commutative property. So I put the 2x by the 4x and I put the 3 by the negative 5. Then the last step is to just simplify, combine like terms. And so I know that 4x plus 2x is 6x. That's where I got that. And then 3 minus 5 is negative 2, and that's where I got my negative 2. Okay? So I made this a little more complicated than it needed to be, just so I was hoping you'd understand what we were doing but with the distributive property. But really, in this case, we just got rid of the parentheses and simplified. That's all we did. One more example. In this example, things get a little bit different. We have to distribute the negative to get rid of the parentheses. And this is what this ends up looking like. Remember how I said there's an invisible 1 in front of all these things if there's no number? Well, a positive 1 times all this just gets us this. But if we distribute a negative 1 times a negative 2x, that's going to make it a negative 2x down here, because a negative times a positive is a negative. And then this negative 1 times a negative 5 is going to make this a positive 5. So that's like the big deal. If there's a negative in front of something with parentheses, you have to distribute that negative sign to both terms. And then we want to arrange the like terms together, just like we did before. We just rearrange it, and then we just simplified. So in this case, 3x minus 2x got us x, and 4 plus 5 got us 9. Really, that's the easy part. The weird part was distributing that negative sign to both the 2x and to the negative 5. Okay? And those are the two examples. If you end up with a fraction or a decimal, so like what I mean is, if this wasn't a 4, it was like 1.2, or this was like 1/2, nothing changes. Treat fractions and decimals just like whole numbers when simplifying expressions that contain fractions and decimals. Okay, that's the end of this video, but your number clue, okay, this is one of many clues. First clue, it's greater than 50. Good luck.